In the previous modules, we've seen how dApps might work with waves. For example, we talked about wallet.write file, and I tried to explain how to work with payment attached to an invocation. In this lesson, we will talk about very interesting types of tokens called non-fungible tokens, about smart assets a bit, and how to work with NFTs and smart assets in our dApp. Let's start with NFTs. And let's take a look at NFTs, at non-fungible tokens. This is a special type of cryptographic token which represents something unique. Non-fungible tokens are those not interchangeable. This is in contrast to cryptocurrencies like Bitcoin or Ethereum and many network or utility tokens that are fungible in nature. NFTs are used in several specific applications that require unique digital items like crypto collectibles, in-game items, certificates, or unique coupons. There is even a specific NFT marketplace built on waves called Item Market. Here is it. Here's an item market. Here you have a list of items for every game. There are 3 games right now. You can buy those items, you can sell items, you can use items bought here in the game. So you can do pretty interesting things here. So in practice, NFTs are just custom tokens with 0 decimals, with quantity of 1, and non-reachable. So users cannot send a fraction of one of those tokens because of the indivisibility. And also, there is one important feature for NFTs in the Waves blockchain. Actually, to issue a token, you should not pay 1 waves as with usual custom tokens. If you have quantity 1, decimal 0, and non-reachable token, then you can pay 1,000 times less fee. So for usual custom tokens, we have 1 waves. For NFTs, we have 0.001 waves. Or in the case of transaction, this is a 1 with 5 zeros, because waves has 8 decimals. Great, so it equals to 0.001 waves. I want to issue an NFT, but I also want to make this NFT smart. It means that I want to apply some logic for this token. Let's create a new file, new write file, an asset script file. Asset scripts are almost like smart account scripts. Here we have an expression which always should return true or false. If it returns true, this operation, this transaction is allowed for this token. Otherwise, this transaction is prohibited for this token, so this transaction will never go to the blockchain. Now, let's write a very simple smart asset code. Here, for example, I want to say that if this token is attached to invocation, so if the transaction with this token right now is invoke script transaction, then I will require that we can send this token as a payment only to our dApp, to our coupon bazaar. Here is an address of our coupon bazaar in the StageNet. So I can say that if this token is attached to invoke script transaction, then the dApp should be address from string value and our dApp's address. Great, so otherwise, if we will try to attach this token to call another dApp, we will get an exception. So we will never be able to send this token to another dApp. And I want to say that only our dApp can transfer this token to a user. How it's going to work? When a supplier adds an item, we want from him to add an NFT to the invocation. So every time supplier adds a new item, they have to attach an NFT. Every time when buyers buy something, they will get not only a record in the key value storage of the dApp, they actually will get a token from our dApp. So they will have a token which represents a coupon. I guess this is pretty simple. So we will allow our dApp to transfer this NFT to users. So it means that we will check that the sender of this transfer transaction, sender, is our DApp. All other cases are prohibited. Great. Now we have a smart asset script with two rules. We can invoke only our DApp, and only our DApp can transfer this NFT token to user, to a buyer. Great. Now copy the compiled version of the code, and we will use it in our issue function, in our issue transaction. Here are all parameters we need, but we have to add script parameter with our just compiled, freshly compiled script. But I have to add something before the body of the script. I have to add base 64 semicolon. And now it looks like it should work. Great. Now let's run this test, only this test, not the whole case. Invalid string length must be multiple of 4. It means that there is an error here, and run it again. Great, now I have a new freshly baked token with this ID. I can go to the Waves Explorer, paste it here, and see the details about this token. Here is one NFT example token with this smart contract code. Here is a smart assets code that we can transfer from this DApp, and we can invoke only our DApp. Great. We issued the first NFT token and paid only 0.001 waves as a fee. Now let's try to modify our Coupon Bazaar marketplace. We have to change the logic of our add item and purchase functions. First, we will require all suppliers to attach an NFT token. How to check that? As you may remember, in our example with wallet, we talked about wallet example, I showed how we can get the payment from the invocation. Here is it. So we can say that in the PMT variable, we have the payment of this invocation. Let's do the same. We have a PMT variable. We get the payment and extract the value to make sure that there is an actual payment. As a next step, we have to check that user attached not Waves tokens, not the network tokens, but attached some custom tokens. How to do that? Let's get the asset ID first. How to get the asset ID? We have a PMT, and from PMT we can get asset ID and we can extract it. So we can make sure that this asset ID is not null. This asset ID is not null. If null, it means that user attached Waves, because Waves is not an asset, it's a native token, so its asset ID is null. Great, now we have an asset ID, and now we can check that this token, this attached token, is actually an NFT. To do so, we have a function called asset info, so we will get some asset details using our asset info function. Here we have to pass an asset ID, so let's pass our asset ID and extract. So we will make sure that there's an actual token with this ID. And now we can check that this token is an NFT. How? We know three main characteristics of any NFT token in the Waves blockchain. The first one is that the quantity is equals to 1. So it means that if this asset details quantity doesn't equal to 1, then there is an error. Also, we have to check that decimals equals to 0. So if it is not 0, then something is going wrong. And the reissuable flag should always be false. So let's say asset details, reissuable. If it is not false, if something, not and, here we need or, if at least one of these parameters is wrong, then we have to throw an exception. Then throw an exception. Attached token is not an NFT. Otherwise, everything is okay. Great. But also, we have to modify this function. We have to store somehow the token ID, the supplier attached to our add item function. So we will need token ID to send that token, that non-fungible token, to a buyer. So we have to store the token ID, the asset ID. So let's just add new data entry, and we will store the asset ID. Asset ID is a byte vector, and we have to build a new key for our NFT. Let's call it get key item NFT, and the suffix is underscore NFT. Great. Now we have get key item NFT, and we store one more key. It means that we will require all the suppliers to attach NFT, but we also have to send this NFT when user buys this coupon. How to do that? Here we have a purchase function, and in the purchase function, first of all, we have to get the asset ID associated with this coupon. How to do that? Let's get asset ID as get binary value from get key item NFT from this contract. So let's check it. This should work. Like we get this binary from this contract by this item. Great, now we have an asset ID, but as a result we have only write set. We have to add transfer set as well. So to wrap these two types of results, we use script result. Script result accepts two types of arguments. The first one is a write set, the second one is a transfer set. So we already have this write set, so we just copy and paste, cut and paste even. And also we have to pass as a second argument, we have to pass transfer set. Transfer set with one script transfer. This script transfer requires a recipient, amount, and asset. The recipient is the caller of this contract, so the buyer. We have only one NFT, so we have to send that one token. The asset ID, we got it from the storage. That's it. Now we require all suppliers to attach an NFT as a coupon, as an actual coupon, and we transfer that NFT token to the buyer. That's pretty interesting. Actually, this step is not required for our final project because there might be some cases where suppliers add an item, but there's more than one token they want to add. For example, they want to add 100 coupons for ice cream. This is the case when we can not use NFTs. We have to use custom tokens. So this example was just to show you how to work with NFTs. Well, let me summarize. In this lesson, we explored an example of how you can add and work with custom tokens in your D app. And we also talked about NFTs and how to work with them, with non-fungible tokens. And we used NFTs for representing unique items. So in the next lesson, we'll create a smart asset by attaching write script to a standard token.